Hi, my second grade friends. I hope that you guys are all doing well. We are going to continue today this unit about materials and properties. Last week was just, a quick little introduction. We started talking about different materials and what those different materials are like, how to describe them, right? We looked at this worksheet and you went on a little scavenger hunt around your house and you tried to find these different pieces of materials: wood, fabric, glass, plastic, and metal. And then you listed them or labeled them in real life. And you probably started to notice that there's a whole lot of different materials in your home, and they each have their own purpose. Okay. And we're going to start to talk about that today. Finding the best material for an intended purpose, right? You wouldn't have a flower vase be made out of paper towels. That wouldn't work, right? You wouldn't have a candle be made out of wood because it would light on fire, right? So we're going to keep talking about materials, their properties, and the best materials for each purpose. Let's get started with lesson 2 today. And we're going to outline today's objectives just because we're going to weave in and out of a few different ideas around properties and materials. So we're going to stay organized. The first thing we'll do is review last week's lesson. And we're going to do that with this fun video called Hunting for Properties. After that, we're going to talk about identifying relationships. And this is a practice or a skill in being a scientist, is identifying relationships. The relationships that we are going to compare are materials and their properties. And we actually practiced this last week too. And then the last thing that we'll do today is analyze properties. So what do I mean by that word analyze? That's another science skill. We'll talk about what that word analyze means. And the reason why we are going to practice analyzing properties today is because it's time to determine which material would be best suited for an intended purpose, right? How do engineers decide what material they use when they're building something or fixing something? They have to analyze the properties of different materials. Let's get started with number 1, review of last week, hunting for properties. All right, so before I start the video, the title again is Hunting for Properties. And I want you guys to do a really good job of listening to all the facts in this review video, because afterwards we're going to do a quick writing piece together, just to make sure that we can wrap up all the information we need to know about properties. All right, here we go.
Hey guys, remember what it was like in preschool? If you don't remember, here's a reminder. It was way easier. Playing with colored blocks, learning shapes, those were the days. Good times. But here's a fun fact. When you were learning how to put all those yellow blocks in a line or stuffing square-shaped blocks through a square hole, you were also learning something very fundamental, and that is how to judge an object's properties. But what do we mean when we talk about the properties of stuff? Well, let's start with this. The stuff that makes up everything is called matter. Doesn't make any difference if it's a tiny grain of sand or all of the air that surrounds the Earth. Everything is made of matter. And a property of matter is just any characteristic that we can list about it, like how it looks, feels, or acts. For example, my characteristics include having black hair, wearing glasses, having some wicked awesome nerd cred, and well, you get the idea. Properties of matter are also things that we can observe. This means that they have differences that are big enough to notice. For instance, I'm currently observing that my desk is messier than it was 5 seconds ago. And to round it out, properties of matter are also able to be measured. That is, we can compare objects to each other. But instead of just looking at them and getting a general idea of how they compare, we measure them by using tools that give us values or numbers. Now, let's put all of these ideas to work by demonstrating how we can find a few basic properties of a simple object. Let me grab my measuring tape. Okay, look. I know I was just talking about how fun it was to play with blocks, but let me be clear. I am not playing with these blocks. This is science, people. Now, let's start with a couple of questions. 1, What properties does this block have? Well, there are some properties that we can observe, but we can't really measure or describe them with numbers, like this block's color or what it's made of, or even the fact that it holds its shape, which makes it a solid. So a better question to ask might be, what can we observe and measure about this block? Let's start with the big one here, length. Length is just the distance of something from end to end, and this block's length is 8.5 centimeters. Width, meanwhile, is the distance of something from side to side, and its width is 8.5 centimeters. Height. That's an easy one. It's the distance of an object from its bottom to its top, not to mention a major factor in being able to play basketball successfully. And the height of this block is 9 centimeters. So length, width, and height are some of the most commonly used properties, but there are a lot of others too. For instance, our block is also an object shaped like a box that takes up space. That is, it fills up the space it's in. We call that space the block's volume. We can measure the volume of this block using math based on the measurements that I just made. But we can also get a more general idea of its volume by making other observations. Like the medium block easily fits into the bigger block, so we know that the medium block has less volume than the bigger block. But there's no way the medium block is fitting into the little block, so we know that the medium block has more volume than this small block. Finally, weight is another measurable property of matter. Weight just tells us how heavy an object is. When you go to a doctor's office and they ask you to stand on a scale, they're using that scale to measure your weight. Got it? Good. So all matter has properties, and properties are observable, measurable characteristics that we can use to tell them apart. And we got to know some of the most common and useful properties that we can put a value or number on, like length, width, height, volume, and weight. So, hey, blocks. Not just for little kids, also super handy for doing science.
All right, boys and girls. So after watching that quick review video, Hunting for Properties, what I want you to do is this worksheet right here. It is uploaded in the Google Documents, okay? And what you can do is one of two things. You can write full sentences, or you can talk about your opinions, your answers out loud with somebody else. So doing a turn and talk. So either or, writing or verbally communicating. All right, and here are some of the responses that Miss Miller came up with. It's okay if your responses are different than mine. But number one, what is a property of matter? A property of matter is a way to describe matter. Just like the girl in the video described herself as having dark hair and being a little bit nerdy, that's how she described herself. We can describe everything in the world. All the matter in the world can be described. Number two, what does observe mean? Observe means to notice differences, right? In Ms. Miller's classroom, we talk a lot about looking closely to observe things. Number three, what is one type of a property that cannot be measured? Properties that cannot be measured include color, material, state of matter, and shape. Number four, what is length? Length is the distance from end to end. And number five, what is one type of property that can be measured? Properties that can be measured include length, width, height, volume, and weight. You could have written any of those. Let's move on to number two, identifying relationships. And we will be identifying relationships between materials and their properties. And like I told you in the very beginning of this video, you guys actually identified relationships last week. When we were doing that sorting activity, we talked about how wood is hard. If you did the follow-up stem bin activity, you decided which stem bin was best for building whatever the object was. That was identifying relationships between materials and their properties. If you look right here at this table, there are 5 boxes with pictures and words. And these are the 5 properties that we're going to talk about today. So the first one says strength, and there's a picture of a weight there because weights are strong. And you can either identify strength as being weak or strong. The next one we're going to talk about is flexibility. And this looks like a paper towel roll, right? Flexibility has two ends. You can either be really, really flexible, or an object can be rigid. So it's very difficult to bend or to maneuver. Next is hardness. The two ends of hardness are either hard or soft. And there's a piece of wood right there. You would describe wood as being hard, right? You might describe a teddy bear as being soft. The fourth property we'll talk about is texture, and it looks like there's two different textures here, something that might be bumpy and something that might be smooth, right? And one end is smooth, the other end of the spectrum of texture is rough. And the last one, we didn't really talk about this too much last week. This word says absorbency, and there's a great picture there. It's a sponge with some water coming out of it. And that's because sponges are very absorbent. You would say, yes, a sponge is absorbent. You would say, no, that, a Chromebook is not absorbent. You would not want your Chromebook to get water in it. And it wouldn't take water in very well. Okay? Let's identify the relationships between these materials over here and these properties over here. So we'll draw lines. All right, it says metal is. Which one of these properties would you say relates to metal? Is it absorbent, strong, hard, rough, or flexible? Metal is strong. Next one, plastic is. How would you relate plastic to a property? Would you say that it's absorbent, hard, rough, or flexible? It's not absorbent. Plastic doesn't usually take in water into its material. It can be hard, but not all the time. It's not usually rough. Let's say flexible. Think about a plastic water bottle. You can bend that. Paper is absorbent, hard, or rough. I wouldn't classify paper as being hard or rough. I would say that paper is absorbent. Think about paper towels. They pick up water and other messes. So they are absorbent. Wood is hard or rough? Well, wood could be hard or rough. Let's eliminate other possibilities. Let's move on to the next one first. Sandpaper is hard or rough? Oh, well, sandpaper's texture is rough. So we'll say that wood is hard. And there's just a couple of examples of identifying relationships. Last, analyze. That is a complicated word, analyze. We haven't really used it much in Miss Millerick's room. We definitely have analyzed before. We've done this skill, but we don't typically say the word analyze. It's new, it's unfamiliar. So I'm going to tell you what it means. Analyze means to discover or determine through careful and detailed examination. Whoa, there's some other big words in that definition. Discover or determine through careful and detailed examination. So basically, what it means to analyze is to use your observations to come to a conclusion, right? You determine through very careful and detailed examination. And boys and girls, you've actually already done this before. Remember when you did that oil spill activity a few weeks ago? You had to determine which material in your house would best pick up the oil spill. So you already know how to examine something carefully. So we are going to analyze some materials for different building situations. So here's the activity that you have for today. You'll see this worksheet. It says material testing at the top. And the purpose of this activity over here is you need to build a bookshelf. Before you can even start to think about what you'll use, you need to really break down what are the properties of a nice, strong bookshelf, a bookshelf that can hold dozens and dozens of books that you like to read. Do you want it to be strong? Do bookshelves need to be strong? They absolutely do. So you would check off strong. Do you need bookshelves to be flexible or rigid? What flexibility level do you want? You want bookshelves to be rigid, right? You don't want your bookshelf to be able to wobble or bend. Do you want hardness or do you want your bookshelf to be soft? Well, probably hard, right? If it's soft, the books are going to fall out. What about texture? Do you want your bookshelf to be smooth or rough? Probably smooth so that you can pile the books in there nicely. And then lastly, absorbency. Do you want your bookshelf to take in water or not to be able to take in water? No, you don't want your bookshelf to be able to take in water because then your books will get wet too. If you look on the bottom half of this worksheet, it says material properties. I am giving you 4 different materials: plastic, paper, wood, and glass. And you're going to do the same thing we just did up here for each of these materials. So you'll go through plastic. Is plastic weak or strong? Check off what you think. Is plastic flexible or rigid? Check off what you think. And when you do it for all 4 objects, you will decide which one of these materials is going to be best suited to build a bookshelf. Okay. And then the next page is just explaining your thought process. All right, boys and girls. So I know that this is a lot of information and there's a lot of detailed work that goes into identifying relationships of materials and their properties and then analyzing what's best for a purpose. But I know and I trust that you will be able to find the best materials for a bookshelf. So I hope you have fun. Bye, guys.